Today topic of discussion is hormones. How to define hormones? Hormones are chemicals secreted by endocrine gland, generally ductless gland. So hormones are chemicals secreted by endocrine gland. It has action on target tissue, and this type of chemicals or substances is known as hormones. Hormones will affect growth and development, sexual function, metabolism, and reproduction. Now moving to classification of hormones. Based on their mechanism, hormones are classified into two main groups. Group 1 and Group 2 hormones. Group 1 hormones, it is based on their receptor. Intracellular receptor. If receptor presented intracellular is known as Group 1 hormones. Intracellular receptor are known as Group 1 hormones. If receptor presented on cell membrane, another mechanism of action is secondary messenger. This receptor presented on cell membrane, another mechanism of action is through secondary messenger. This hormone belongs to group 2 hormones. Again, these group 2 hormones divided into 4 groups: group A, group B, group C and group D. Group A, cyclic adenosine monophosphate, is secondary messenger. Group B, cyclic GMP is the secondary messenger. Group C, if calcium or inositol phosphatidyl. In group D, kinase or phosphatase. These hormone acting as a secondary messenger, they belongs to group 2. So group 2 hormone further divided into 4 groups: A, B, C and D. Now discuss about difference between group 1 and group 2 hormones. Group 1 hormones, there are lipophilic in nature, lipid soluble in nature, cell membrane bilipid layer, so group 1 easily travel or pass to the cell membrane. It is lipid soluble in nature. They have long lifetime in hours to days. They required transport molecules. They have intracellular receptor. Next, they have that mediator. They act by forming hormones receptor complex. Second, group 2. This one is hydrophilic. They cannot travel to cell membrane. Have the receptor presented on cell membrane. After binding of hormones to cell membrane receptor, they send a message which is called cellular response. They have cell membrane on the receptor molecules. They are hydrophilic in nature, short lifetime, minutes only. They don't require transport molecules. They have they are having cell membrane of target tissue. They act through second messenger. These are the basic different. Group 1 lipophilic, lipid soluble. This one hydrophilic in nature. Then lifetime few hours to days. This one minutes only. Then they require transport molecules. Here they don't require transport molecules. Then group 1 is the intracellular receptor. Here cell membrane of target tissue. Then this one mediator act by forming hormone receptor complex, here through secondary messenger. These are the difference between group 1 and group 2 hormones. Coming to examples of group 1 and group 2 hormones. Group 1 hormones include steroid hormone. Steroid hormones, glucocorticoid, mineralocorticoid, androgen, progestin, estrogen, calcitriol, then thyroid hormone T3, T4 and retinoic acid. This thyroid hormone T3, T4 and retinoic acid, they act as intranuclear receptor. So these are the group 1 hormone examples. Glucocorticoid, mineralocorticoid, androgen, progestin, estrogen, calcitriol, then thyroid hormone and retinoic acid. Second one is group 2 hormones. Group 2A. Secondary messenger is cyclic adenosine monophosphate. That group A include adrenaline, glucagon, follicle stimulating hormone, then luteinizing hormone, then melanocyte stimulating hormone, adrenocorticotropic hormone, parathyroid hormone, calcitonin and somatostatin. These are the hormone comes under group 2A. Next one is group 2B. Here that secondary messenger is cyclic GMP. Two examples only: nitric acid and ANF, adrenal natriuretic factor. Then group 2C. Here that secondary messenger is calcium or phosphatidyl inositol. It include oxytocin, gonadotrophic releasing hormone, then gastrin, then cholecystokinin, then thyrotrophic releasing hormone, then platelet derived growth factors. So group 2C hormones examples: oxytocin, gonadotrophic releasing hormone, gastrin, cholecystokinin, thyrotrophin releasing hormone and platelet derived growth factors. Then group 2D. Here the secondary messenger is kinase and phosphatase. It include growth factor, prolactin and insulin. These are the examples of group 1 and group 2 A, B, C, D hormones examples. So we discussed important group 1 and group 2 hormones example. Next we'll discuss about a sequence of events in the group 1 and group 2 hormone action. First one is group 1 hormones. These hormones can travel to cell membrane and it bind to the intracellular receptor. Hormone group 1 can travel to cell membrane and it binds to the intracellular receptor. So first one, here hormone receptor complex formation, then binding this hormone receptor complex to hormone responsive element, then activation, transcription and synthesis of protein, then next process expression and biochemical response. So these are the event of mechanism of action of group 1 hormones. First one is this hormone can travel to cell membrane, bind with intracellular receptor. First that hormone receptor complex formation will occur, bind with the hormone receptor complex to hormone responsive element. After that activation, then transcription, then synthesis of protein, then expression and biochemical activity. Second one is group 2 hormone bind with the cell surface receptor, bind to the cell surface receptor, which leads to the activation of G protein. Then this activation of G protein leads to activation of protein kinase. So this protein kinase leads to the phosphoprotein and leads to this phosphoprotein which responds for biochemical activity. So bind with cell surface receptor, then leads to activation of G protein, then leads to activation of protein kinase, then leads to phosphoprotein, then it is responsible for biochemical activity. So these are the event of mechanism of action in group 2 hormones. Now discuss with the mechanism of group 1 hormones. It acts to intracellular receptor by forming hormone receptor complex. Considered it is a cell membrane. This one is the hormone or ligand. Can travel to that cell membrane. It is nucleus. It containing nucleic acid, genetic material, DNA is presented. This hormone can travel to cell membrane. It is lipophilic in nature, so easily travel to cell membrane. It entered to cytoplasm. Now this hormone entered to cytoplasm. Here receptor is presented. Where receptor, it will attach with heat shock protein. It will attach to this receptor attached with heat shock protein. Now this hormone will binding with the receptor to these conformational changes in that receptor molecules. This heat stable protein, this heat shock protein detached. Now these hormones passes to that nuclear membrane and it get attached to that hormone responsive element. In this nucleic acid, here the DNA, here hormone responsive element is presented. If it is glucocorticoid, means here glucocorticoid element is presented. This receptor hormone complex attached with hormone responsive element. It activate number of factors. It will activate number of factors which stimulate translation and transcription. After activation of different factor, there is synthesis of mRNA. By the process of transcription, then form this mRNA, this is synthesis of protein. This protein show biochemical response, it action. So this one is hormone will enter to cell membrane. In the cytoplasm, receptor is presented. That receptor will attach with the heat shock protein. Then here detachment of heat shock protein. Then this hormone will enter to that nucleus. Then here hormone responsive element is presented. After that it will activate, after binding with the hormone, it will activate number of factor, then synthesis of mRNA. From this mRNA synthesis, it will synthesis protein molecule. It will show various biochemical response. So in the case of retinoic acid or thyroid hormone, means this one is retinoic acid or thyroid hormone, which are intranuclear receptor, in which what happen, it travel into a cell membrane. It will travel to a cell membrane. There are lipophilic in nature, then enter to that cytoplasm, then it will travel to that nuclei. It will travel to that nuclei. and attached this hormone with the receptor, it will release this negative effector. And there are number of positive factors which get stimulate and causes formation of mRNA and protein, which shows biochemical response. So that summary of glucocorticoid and that retinoic acid. First one is hormone travel to that cell membrane, then enter to that cytoplasm, then bind with the receptor, heat, shock protein detachment, then it will passes to that nuclear membrane and attached with the hormone responsive element. Then it activate number of factors. Synthesis of mRNA will occur, then it shows biochemical response. In this case of thyroid hormone, means thyroid or retinoic acid, means they have intracellular receptor. They cross cell membrane, then they enter to that cytoplasm, then it will enter to nucleus, bind with the hormone responsive element, that negative effector get detached, then it will activate number of positive receptor, which causes transcription, translation and synthesis of protein. It shows biochemical response. This is mechanism of group 1 hormones. Next, mechanism of group 2 hormones. Cyclic adenosine monophosphate, G protein, calcium inositol cascade and insulin action. Sequence of event in group 2 hormones. They first bind with cell surface receptor, then they causes release of secondary messenger, then secondary messenger process activation of protein kinase, and protein kinase will activate protein, then it converted into phosphoprotein. Protein is converted into phosphoprotein, that shows that biochemical response. So what are the mechanism? First, this group 2 hormone bind with the cell surface receptor. They causes release of secondary messenger, then secondary messenger process activation of protein kinase, and activation of protein kinase will activate protein molecules, and it will protein is converted into phosphoprotein, then only it shows that biochemical activity. So this is the sequence of event in group 2 hormones. Group 2 hormones, first one is A, mechanism through G protein coupled receptor. Group 2 hormones, they bind with the cell surface receptor. After binding, they causes activation of G protein. G protein causes activation of protein kinase. It converted into protein to phosphoprotein. It shows that biochemical response. Okay, here G protein, it is heterotrimeric protein. G protein is a heterotrimeric protein. Now coming to G proteins coupled receptor. Mechanism of action of group 2 hormones through G protein coupled receptor. This one is 7 transmembrane domain attached with gamma subunit, beta subunit, alpha subunit and GDP. This GDP is G protein. Then this one is receptor G protein. This one is effector molecules. These are the things considered as effector molecules. adenylyl cyclase, phospholipase, calcium, then cyclic GMP phosphodiesterase. These are the molecules considered as effector molecules. So this one is 7 transmembrane domain. There is attachment of gamma, beta, alpha, GTP. This one is the G protein. Then this one is the receptor G protein. This one is the effector molecules. It may be either one: adenylyl cyclase, phospholipase, calcium, cyclic GMP phosphodiesterate, sodium chloride, like that. It can be any one. On binding hormone to that receptor, binding hormone to the receptor for this activation in the form of filtering occur due to GTP activate this one, due to this one glitting of 7 transmembrane domain. Glitting occur due to GTP activity. Then it will separate alpha, beta, gamma. Now it become active. When it will separate alpha, beta, gamma, now it active. These separate molecules will change these effector molecules. These separated molecules will change effector molecules and the change biochemical response. So it will change it that biochemical response. Now coming to mechanism of action of group 2A hormones. Group 2A hormone through cyclic adenosine monophosphate. This is plasma membrane. Then it is protein adenylyl cyclase. It is effector which activated by G protein. Adenylyl cyclase causes conversion of adenosine triphosphate into cyclic adenosine monophosphate, and this cyclic adenosine monophosphate can be converted into 5' AMP adenosine monophosphate by the phosphodiesterase enzyme. Now this cyclic adenosine monophosphate act on protein kinase, which is composed of R2C2 unit. It is inactive protein kinase. This cyclic adenosine monophosphate bind with R2 subunit and it causes activation of protein kinase. C2 is catalytic unit, R2 is regulate unit. Cyclic adenosine monophosphate bind with R2 unit and it causes activation of protein kinase. Activation of protein kinase. Now C2 unit activated. Now this activated unit which causes conversion of protein into phosphoprotein. Protein into phosphoprotein which shows response. Again it converted into protein by removal of phosphatase. Response can be removed by phosphatase and phosphodiesterase. So plasma membrane, it have that enzyme adenylyl cyclase. Then adenylyl cyclase is the effector activated G protein. This adenylyl cyclase causes conversion of adenosine triphosphate into cyclic adenosine monophosphate. This CAMP is converted into 5' AMP. This CAMP, the cyclic adenosine monophosphate, act on protein kinase composed of R2C2 unit. Now this CAMP bound with R2 unit which causes activation of protein kinase. Now C2 unit activated and causes conversion of protein into phosphoprotein. It shows response. Again the phosphoprotein is converted into protein by the removal of phosphatase enzyme and phosphodiesterase enzyme. Next, group 2 B hormone through cyclic guanosine monophosphate act as secondary messenger. Here examples NO nitric oxide and ANF atrial natric uretic factor. Then group 2 C hormones, secondary messenger calcium and phosphatidyl inositol. This is hormone bind with a receptor which is presented on cell surface. This one is the membrane. This receptor presented on cell surface which causes activation of G protein, and G protein activate phospholipase enzyme. This one is the effector molecules. Hormone bind with a receptor which is presented on cell surface which causes activation of G protein. The G protein activate enzyme phospholipase. This phospholipase C enzyme causes conversion of phosphatidyl inositol bisphosphate to diacetylglycerol. So this phospholipase C enzyme activate conversion of phosphatidyl inositol bisphosphate to diacetylglycerol and inositol triphosphate. G protein is also increasing that calcium movement. This G protein also increasing calcium movement. This inositol triphosphate, it release calcium from endoplasmic reticulum. That calcium bind with calmodulin to form calcium calmodulin complex. It activate various specific kinase. This calcium calmodulin complex activate various kinase. This one uses for conversion of protein into phosphokinase. It shows its effect. So hormone bind with a receptor, it will activate G protein. The G protein activate phospholipase enzyme C. Now this one converted this phosphatidyl inositol bisphosphate to diacetylglycerol. Now this inositol triphosphate, this one will activate protein kinase enzyme. This G protein also increasing calcium movement. This inositol triphosphate release the calcium, then it will bind with the calmodulin, then calcium calmodulin complex will occur. It will activate various kinase, conversion of protein into phosphokinase, then it shows its effect. Then this calcium directly activate this calcium directly converted protein to phosphokinase, then it shows its effect. Then group 2 D hormones. Coming to group 2 D hormones, kinase phosphatase cascade. It mainly include insulin hormone, growth hormone, prolactin. This is insulin receptor. Tyrosine molecules present inside of receptor. Tyrosine molecules presented inside receptor. It is a intrinsic. Once tyrosine activating, this one is intrinsic tyrosine activating. Once attachment of insulin causes phosphorylation of Thiamine causes phosphorylation of tyrosine. It causes activation of tyrosine molecules. It causes activation of tyrosine molecules, which causes activation of insulin receptor. Which causes activation of insulin receptor. Substrate 1,4 by phosphorylation. Insulin receptor substrate 1,4 phosphorylation. Due to this phosphorylation of insulin receptor substrate, it causes activation of various protein kinases and also lipid kinases. It also activates some factors MSOS and mammalian son of Savanless and GRB2 growth factors receptor binding protein. It shows biological effect. MSOS and or GRP2 activate various kinases in the form of DNA synthesis, growth factor, and early response. These protein kinases and lipid kinases shows its effect in the form of protein translocation, activation of enzyme transcription and translation. So this one is insulin receptor. Inside it have that tyrosine molecules. Once attached to insulins, it causes phosphorylation of tyrosine, which causes activation of tyrosine molecules, which causes activation of insulin receptor substrate by 1,4 phosphorylations. Then it will activate various kinases, protein kinase, lipid kinase. It will activate as various kinases. It shows its effect in the form of protein translocation, activation of enzyme transcription and translations. Thanks for watching.